All right, so the difference quotient is given as the formula f of x plus h minus f of x divided by h. So the first thing is, let's go over this example. Let's say we want to compute the difference quotient for the following function. Let's say 7 minus 5x. If I want to compute the difference quotient for our given function, your very first step, step number one, is to compute f of x plus h. Okay, so step one, compute f of x plus h. So what does this mean? This means that wherever I see an x, I am going to replace it with x plus h. So look at your function. How many times does the variable x appear? Just one time. That particular x is going to be replaced by x plus h. Okay, so f of x plus h is now, for this function, is going to be 7 minus 5 times x plus h. As you're computing f of x plus h, you have to expand it. So the way that the expanding is going to work in this example is you distribute the -5 inside of the parentheses. So this will give us 7 minus 5x minus 5h. And that's your first step already completed. We proceed with step 2. So my step 2 is where I put this in quotes. It's the longer of the two steps. That's where I tackle the difference quotient. Okay, so step 2, put this in quotes. I'm going to say that we tackle the difference quotient. And here's how that works. First of all, in your formula for the difference quotient is given as f of x plus h. Now, I know the terms that belongs to f of x plus h. Those terms are exactly 7 minus 5x minus 5h. Personally, what I like to do, or what I tell my students, is that I want to keep the f of x plus h terms separated from the original function, namely f of x, by using brackets. Brackets make your life easier when you solve this problem. So observe. We have 7 minus 5x minus 5h. That goes inside the first set of brackets because that's your f of x plus h. Minus f of x, which is the original function, 7 minus 5x. All of this is being divided by an h. The reason why I like to put the things separated in brackets is because whatever terms the two brackets have in common, you could just cancel it out since they're separated by that minus sign. So what terms, everyone, can I cancel out? 7 and the -5x. That's right. That's exactly what they have in common, the two brackets. So what are you left with? You're going to be left with -5h all divided by h. Now, can you reduce this ratio, -5h over h? You could cancel out the h. If you cancel out the h, what are you remaining with? You're -5. And this makes sense as to why our answer is -5. I just want to point this out. If you look at your function f of x, which is 7 minus 5x, what type of function is this? Namely, what would the graph of this function look like? Do anybody know what the graph of 7 minus 5x looks like? Yeah? Well, it won't be a horizontal line. This is actually just a straight line. It's a straight line. And one of the important characteristics about a line is finding what? What is when you're dealing with equations, linear equations, what is one of the most common thing that you like to, or you're often asked to find? The slope. My slope in this example is, when you look at this function, is what? Not -5x, but just -5. So in this problem, your m value is -5. Do you see a correlation here? The correlation is that when you're dealing with the difference quotient is just a fancy way of saying slope. It's just a fancy way of saying slope. And since we're dealing with a linear function in this example, the difference quotient answer is equivalent to whatever my slope is. All right? So just a side note, let's say if I had the function, I'm not going to do the entire difference quotient, but let's say I had g of x is equal to 3x minus 5. What is my slope here for the function g? G, yes. For function g here, the slope is 3. When you apply the difference quotient, you're also going to get the value 3. Now, this only works when you deal with linear functions, namely when the graphs are straight lines. When you deal with functions that are no longer linear, this idea of, the difference quotient is going to be equivalent to the slope does not apply. And I can show you with the second example. So let's look at part B. Let's say in part B, I give you g of x is equal to negative 5 times, negative 5 times x squared plus 3x minus 18. Do anybody know what the overall shape of this graph is going to look like here? So what type of shape did you just draw? What type of shape is it? It's a U shape. U-shaped graphs are called what? Parabola. So we're dealing with a quadratic function here in part B. Because we're dealing with a quadratic function, you're no longer dealing with a linear function. So when I apply a difference quotient, I can't say that my answer is going to be negative 5 or my answer is 3 here. Okay. So how do I use a difference quotient? Well, step number 1 is, again, to compute. This time, you're going to be computing g of x plus h. Okay. So how do I compute g of x plus h? The way I compute this is wherever I see an x, I'm going to replace it by x plus h. Now, how many times does the variable x plus h appears? Say it louder. They appears twice. You have the variable x appearing when you have x squared, and then when you also have the 3x. So by substitution, you have negative 5 times x plus h squared plus 3 times x plus h minus 18. So you have to expand this. So just aside here, what you need to do is first expand the x plus h squared, right? So if you look at x plus h squared, it's the same thing as saying x plus h times x plus h, okay? If I want to FOIL this out, I do x times x, which is x squared. Then I do x times h, which is xh. Then I do h times x, which is xh. And then I do h times h, which is h squared. Okay? So just note that when I did h times x, it's hx, but hx is the same thing as xh. Okay. So when you FOIL, sometimes you also got to look at if you can combine like terms. Is there any terms that I can combine? Yeah, the middle terms. How many xh's do we have? 2. So this will give us x squared plus 2xh plus h squared. So I'm going to replace that into my formula. What we're going to have is negative 5 times x squared plus 2xh plus h squared plus 3 times x plus h minus 18. Now what I'm going to do is FOIL, or distribute. Sorry, not FOIL, but distribute. I have to multiply negative 5 inside the first set of parentheses and multiply 3 in the second set of parentheses. If I multiply negative 5 inside the first set of parentheses, this will give us negative 5 times x squared minus 10xh minus 5h squared plus 3x plus 3h minus 18. Now, can you combine any like terms after I expanded here? Yes or no? No, you cannot combine, and there's no like terms here. So this is exactly g of x plus h. So step 1 is now completed. Once step 1 is completed, you move on to step 2. Okay? So step 2 states that we tackle the difference quotient. So when I have the difference quotient here, I can just rewrite it in the terms of g. It's g of x plus h minus g of x all divided by an h. So what do I like to do with the g of x plus h and the g of x? What do I like to put around them? You put brackets. So I'm going to put a bracket around the g of x plus h terms, which are precisely negative 5x squared minus 10xh minus 5h squared plus 3x plus 3h minus 18 minus the original function. What's my original function? My negative 5x squared plus 3x minus 18. And all of this is being divided by an h. All right, so this is now helpful when it's inside of the brackets because whatever terms they have in common, because the minus sign is in the middle, you just cancel them out. So what terms can I cancel out? Well, careful, you gotta say negative 5x squared. There you go. 3x, negative 18. So there's a pattern here. When you're doing the simplification, the difference part, the subtracting, all the terms of the original function is going to get wiped out. The only terms that are going to be remaining are terms that includes an h. So this will give us, careful, negative 10xh, negative 5h squared. No, you forgot one other term, plus 3h. Plus 3h all divided by an h. Alrighty. Now what can I do? I did the difference part. Now we do the quotient. Quotient is just another way of saying division. You could factor the h out first from the numerator and then cancel it out with the h in the denominator. So if I factor the h out from the numerator, this gives us negative 10x minus 5h plus 3 all divided by h. So as long as we say in calculus h is not equal to 0, the h's are canceled, you get negative 10x minus 5h plus 3, and that will be your final answer. All right, so I'm going to zoom out a little bit, and then I'm going to stop this video for questions.